Are there any questions before we get going? Yeah.
What day is the in-person class?
What day is the in-person? There's two of them.
Okay, I'm in the online section.
Okay, so there's the Thursday and Friday, and they're like 2:15 to 4:05. Why do you ask?
Are you doing any recordings of those?
No.
No.
No, there's no recordings of the lab. Did you want to register in one of the in-person ones?
I might look at it now.
Okay, yeah, because you can, if there's spots available, you can register in, but you'd of course have to then show up. Any other questions? All right, so last time we ended off with that question, what's wrong with this statement? Or not wrong with it, but when you think formally and whatnot, what's peculiar about the statement, this statement is false? It's paradoxical, right? Who said that? Over there somewhere? Yeah. So why is it a paradox? Well, let's think. Let's start by assuming that when I read this statement, I should trust it. Okay? So if I read this statement and I trust it, it tells me what? It says, okay, this statement is false. But hold on. If I am to believe what this is telling me, that then therefore means that the statement is actually false. And if I'm to believe this, that would then therefore mean that the statement couldn't be true, therefore I shouldn't trust that it says it's false, it should therefore be true. And do we see the problem? There's a couple of similar ones out there. Of course, I can't think of any of them right now. And we'll talk a little bit more about these as we get to the end of the semester. But another funny one is like, what will happen if Pinocchio says, my nose is going to grow now? Because when does Pinocchio's nose grow? When he lies. So, if his nose grows, that means that he's lying. But if he just told us that his nose is about to grow, and it grows, then that means he isn't lying. Long story short, Pinocchio should never say that sentence, unless who knows what happens. That type of stuff is in the weird, heavy-duty areas of computer science that we're not really going to touch here, but some pretty interesting stuff goes on there. So there's some terminology we're going to use. Hardware, software. Hardware, that's like the physical stuff, like your computers, your mouse, your keyboard. Physical stuff. The software, that's like the programs running inside the computer. It's not really physical, but it's still doing a lot of important stuff. What else we got? I/O. Who here knows what that means? Somebody yell it. Input, output. There you go. I/O, that's a popular word. Input, output. What's some input to a computer? Well, that would be like keyboard, mouse clicks. Output, video, sound, whatever. By the way, this isn't like on the test type stuff. It's just terminology, just so you're familiar with it. What else? Processors, that's like the thing crunching all the numbers in the computer. Hard drive, that's where we store all the stuff, like that's our long-term storage. All those programs that you have on your computer that like you're not using right now, all the information about how to run them and whatnot is stored there. RAM? Who knows what that one stands for? Well, it's somebody else. I guess you're someone else.
Random access memory.
Random access memory. This stuff is really important in your computer. How many of you have at least heard the phrase RAM before? Of course, everybody. How many people don't really know what it is, but you know that you want as much of it as possible? Yeah, of course. RAM is like the workspace your computer has. Imagine like you've got a countertop that's very small, and your fridge is like the hard drive. Maybe the fridge in your cabinets, that's where everything's stored. Everything that the computer's actively doing, it's like, it's using this countertop. Wouldn't it be great if you had a much bigger countertop? Because then you have so much more room to work and do your stuff. So that's kind of the idea there with RAM. What do we got? Binary. Raise your hand if you've heard this one before. Of course. Binary. No I'll give you perhaps a slightly more formal definition that you're used to, is binary is a number system. Like, we have a number system where we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What comes after 9? 10, 1, 0, yeah. What comes after 10? 1, 1, 11. So binary is similar, except we only have two symbols. 0, 1. We only have two of them. So we know that the value 3, I guess the value 2 comes after the value 1, right? But we've run out of symbols in a binary world, so in order to get 3, we have to kind of do the same idea like we did with 10. Kind of add a 1 and move it over. So in binary, 0 is 0, 1 is 1, and then 1, 0, which looks like 10, is actually 2. Long story short, we use binary in our computers because we can break everything down to these zeros and ones. And we like this because when we implement this physically on the computer, we can represent zeros and ones physically with low voltages and high voltages. So that's kind of how everything gets encoded, so it works mechanically on the computer in the electronics, and then all the way up to what we see right here. That's a long-winded way of saying, oh, zeros and ones, right? Who here was familiar with that version of the definition? Yeah, that's zeros and ones. You probably haven't put that much thought into binary though, right? What else? Compiling, well, and then we've got interpreter, IDE. These are a lot of big words. Some programming languages are what we call compiled. You write a program, but it's just a bunch of code, right? The computer doesn't actually know what the code is. We've got this thing called a compiler that turns that code into the zeros and ones that go run on your processor. There's some steps in between, don't get me wrong. Now, interpreter though, an interpreted language like Python, you don't actually have to compile, it just kind of goes run through this fancy interpreter thing. And an IDE, who here's heard that one before? One person, 2.5. That's just it means, is it integrated or interactive? I always forget. Integrated development environment. It's basically a fancy word for a big program that you write code in that does a lot of help for you. There's a bunch of them available for Python. We'll probably look at some of them later in the course. But anyways, this type of stuff is just going to become second nature to you as you go. In fact, we're not really going to be talking much about hardware, software, processors, hard drive, RAM, maybe a little bit about binary, not really anything about compiling. So anyways. So for fun, just to make sure you're all on top of it, you haven't gotten rusty, take 2 minutes if you've got your laptop here, open up Colab and write write a line of code. Maybe print out something, whatever you want, some message. Try it, go, do it. I'll give you a minute. Yeah.
I just got into this class, and I'm not on the Moodle account.
All right, then send me an email so I can add you.
The same.
Send me, if you don't send me an email, I won't be adding you.
I just,
Good, cool. Good, I like it when more people show up. It's a good thing. And of course, the website that we're usually using for the 2 new people, it's the one that we were just on. The easiest way to get to it is go to CSCI161.com. It takes you right there. There's a link to it on the Moodle webpage. But all the content that we're going through is on the 161 website, not Moodle. Moodle's just used for submissions. So who here's got their witty message working? Who here did it, but it didn't work? A couple people? Let's see if I know why it didn't work for those couple people. When I hit run, what's going to happen? Error. Why? Oh, we need those quotations. Right, we want to print out the string. When Python sees hello without the quotations, it just thinks, oh, that's another piece of like code. And then when I hit run, it's going to go look for the piece of code that connects with hello, but that doesn't exist. So then it'll say something like, what does it say? Name error, hello is not defined. I don't know what hello is. I can't do anything with that because we didn't put it in quotes. We actually wanted the value hello, where the value, that's like the string. So we put in our quotes, and I hit run. There we go. Perfect. Works good. Great. That's it. That's it. That's it for that activity. So don't forget those quotes when you're printing out strings. Now, you don't need quotes when you're printing out things like numbers. It'll just print it out. But you could add quotes, and it still works, but there is a bit of a difference in what's going on here that we're going to talk about in like 2 seconds. So, values and types. So, in computer science, when we're writing code, it has a lot to do with the values of certain things. So, for example, the string hello. I printed out hello. Or the example here is A, B, C, D, E, F. It's in quotes, so it's a string. That string has the value A, B, C, D, E, F. It's pretty, obvious, but it's got that value. Now, we also can have things like numbers, 7, 42, and 97. What value do you think 97 has? It's not a trick question. I guess it kind of is a trick question. Somebody say 97. 97, hey, there you go, yeah. The integer 97 has the value 97. It's an integer. And then weirdly, we have things called floating point numbers in programming. Now, you might think, but why? We already have integers. Well, the floating point numbers are numbers where we can have decimals. And with integers, we're not allowed to have decimals. So we call these floating point numbers, like 3.792, or 0.000000000005. I think I said the right number of zeros. Those are floating point numbers. So the number 3.792, what value do you think that has? It's easy to get. 3.792, yeah, that's it. So we call these things literals. And the reason we call them literals is they literally have the value that they have. You know, I mean, that's not why, but that's the way I like to think about it. 5 is literally 5. What value does 5 have? Well, it's a literal, so it's just 5. What value does the string ABCDEF have? ABCDEF. It's literally that. Notice how, though, I also talked about the types here. I've been emphasizing types a lot. And types are critically important. Some programming languages are a little nice when it comes to types. But of course, a lot of times in programming, niceness comes with the ability to make it easier for you to mess up. And some programming languages are very, very strict about types. You got to be very careful how you're doing things in mixing types, because it just won't work if you do. But usually, if you hit run and it doesn't work because you're mixing types, it actually, if and when it does run and there's no type issues, then you're more likely to be correct. Less of a chance to have logic errors and whatnot. So so far we've seen strings, integers, and floats. There are a lot more types, and eventually we're going to be able to make our own types. But right now we've seen these 3. So let's do a quick test. If I say 17, what type do you think that is? Integer. Why? Because it's an integer. What if I say 17.0? It's a float. Even though 17 and 17.0, they've got the same value, they actually have like different types. And what if I do quote 17 close quote? 17, but that's also a different thing. It's the string 17, which is very different than the integer 17. So types are very important. And the cool thing is we are able to ask the computer what the type is. So I already said this bit, but we can ask the computer what the type is. So if I want to do type of this, and I print it out, what do we expect to see? On the count of 3, everyone should yell. 1, 2, 3. Stir. Yeah, close enough. Stir. What do you think that means? String. Now, what if I do this? What do you think we'll see when I hit run? Int. What do you think int means? Integer. What if I do, ooh. Is that what you thought? Good. There's another one too. What if I do this? I guess it's uppercase. Bool. Ooh, that's another one we'll learn about very, very soon. So we can ask Python what the type of stuff is. So there I'm saying print type 12, it's an int. Shouldn't be a surprise. Why is it an int? Well, because we've been familiar with integers since we were this big. Witty remark, that's a string. Why? Well, I guess in computer science we like to call like words and sentences strings. We call it because it's like a string of characters. In other programming languages, there's like a whole other type called a character, which is a single letter, which is actually different than a string of letters. It's weird. Don't worry about it. It's not going to come up in Python. 3.75, well, that's a float, and 1.1. What do we have there? Oh, wait a minute. What's going on in that last line there? Somebody else. What do you say back there?
You put the type in twice?
I put type in twice. So here's what's interesting. Let's think for a second what it's doing. And by doing this, we'll see a little bit of how it's going to work. So what Python's going to do is first thing it's going to do is go into like the most smallest amount of go into all the brackets it can and then start crunching the numbers and work its way back up. So we're saying print the type of 1.1. So first it's going to go on and be like, okay, I've got 1.1. And what is the type of 1.1? Float. 1.1 is a float. Why? It's got a decimal. So it's a float. But that, when I call type 1.1, it returns, let me show you. See how it says class float? So this is the type of 1.1, not the type of 1.1. So when I ask, what is the type of 1.1, I'm now asking, okay, what is the type of class float? And the type of class float, well, that's just a type. So I asked this number, what's your type? And then type 1.1 says, oh, I am the type float. And then I ask the type float, what is your type? Python says, oh, you're just a type. It's kind of weird, but it's the way it is. So there's another example of a type. If you're ever wondering, why would I want to do this? Because I can. You'll notice in computer science, the best way to learn stuff is to learn what the rules are and then do weird stuff with the rules. Like, can I do this? Can I ask what the type of the type is? Try it, see what happens. Oh my gosh, it gave me, well, here it didn't, but in the previous example it did. So it's always fun to know what the system is and then do the weirdest stuff you can with that system, because usually when you do that, that's where the fun stuff comes from. But we'll get there. But, okay, so I may have already spoiled this fun, but let's do this real quick. Write a single line program to print out the integer 1. Now write a single line program to print out the string 1. Can you tell the difference by looking at the output? I kind of already spoiled this for us, but extra. So this is the output of the integer 1. This is the output of the string 1. Can you tell the difference between the two? No. So when we're talking with literals, it's often kind of easy when looking at the code itself, when we're talking about literals, we can pretty much know what the type is going to be. But once it comes to the output of the program, it's going to be a hell of a lot harder. And once we start talking about things called variables, that's where things are going to become quite problematic. Because you might not remember or know what the type is. Variables. Okay, are there any questions so far about types? Now's the time to ask because we're blowing past types now. We're going on to variables. No questions at all. Everyone's okay. All right. So, variables. This is probably the first super amazing, important feature of programming languages that you're going to learn. This right here is like one of the critical ideas that changes everything, that makes everything that you're going to do possible. There's a lot more of these things in programming that are coming up, but you best pay attention to this because this is exceptionally critical. Going forward, you're going to be using variables forever. All the time, forever. So, a variable is, and I was talking about this in lab yesterday, a variable is kind of just like having a box that we can store information. Okay, for later. I'm going to store this information for later. So we see that line of code there where I say a equals 5. That tells the computer, okay, go to the right-hand side of that equal sign. What do we have there? The integer 5, right? How do we know it's an integer 5? Well, we can know just from looking at it. It's the integer 5. Why is it not a string? Well, there's no quotes. But as soon as I say a equals 5, here's what happens. Python's going to go, oh, okay, so I'm creating a variable now called a. Why a? Because that's what the code says. I could make a almost anything I want. Almost. There are some limitations. So it's saying, go create a box called a. And even though you may have never seen this before, what value do you think I'm going to put inside that box? 5. A couple people were going like this, and I was like, why are you raising your hand? Oh, you're 5. That's what you were doing, right? Yeah. So inside of this, we put 5. So now, later, I can go back and say, hey, what's the value in A? And it'll tell me, what do you think? 5. Why? Because that's what's in there. A funny thing about computer science, too, to be warned, and I told this to the lab yesterday, don't think too hard. It seems like weird advice, but a lot of mistakes happen when you try to do too much and think too hard at once. Slow it down. Take it easy. Computer science, computer scientists aren't bright enough to do anything more sophisticated than like, okay, step 1, put the value 5 in a box called A. Okay, great. Anything more than that, we're in trouble. So what do you think is happening in the next line? Who wants to boldly tell me what they think is going to happen? Analogous to this right here. I'm going to point to someone if I don't get it. What do you think?
N will be equal to a string.
Yeah, so it's like we're making the box. And what are we putting in it?
String.
Variables are fun. So the string, whatever, blah, blah, blah. Pretend it's the same one. We're not putting string in it. We're putting the string with the value. Variables are fun. Just like in here, we didn't put int in it, we put an integer with the value 5. The value 5 that has the type integer is in the box. It's about the values. But here's the funny thing. Let's go here. If I say a equals 5. Great. So now in a, there should be the value 5. So, if I run this code, what should the output be? Everybody say 5. Why? Well, because I told Python, print out the literal 5. So that 5 in that print, it's got the value 5 and it's an integer. And then we said print it out, so Python just did it. That's it. But here's the thing. What happens if I do this? Print out A. So you may have never, raise your hand if you've never used variables before like this. Really high, I want to see. Really, really high, really high, really high. Okay, you. Even though you've never seen this before, let's see if you can tell me, like, what do you think will get printed out? A, but what value does A have? You don't know? What? Why? Because it said right up there. Why? Well, because A is the variable that now has the value 5. That's an integer. So there are literals that have values. 5 is 5. But variables can also have the values too. The values that are like in the box. We're going to be using variables a lot. What do you think is going to happen if I do this? Take a second, think about it. So raise your hand if you've never used variables before. Really high, I want to see. What do you think is going to happen? Yeah, you.
9.
Why?
Because you said A equals 5 and they got
Exactly. Because A has the value 5, and then what is 5 plus 4? 9. And then what do we do with it? Print it out. So let's see if you're right. 9. So now you might be thinking, okay, great, but why do I care? Well, maybe this will kind of help give you a little maybe what I'm about to do will foreshadow a little bit as to why this is really great. I'm going to hit run and turn this into 3. And now I'm going to hit run again. Take a second. Think about what you think the answer is going to be. Don't yell it out loud. And I'm going to hit run. Raise your hand if you were right. Good. Very, 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 very good. Why? Well, now I said, okay, A, you're 3. And then later when I say, okay, what's A plus 4? Python's going to go, okay, A plus 4. Well, what value does A have? And then it's going to go look, and it's going to say, okay, it's 3. And then what's 3 plus 4? 7. Let's see what happens if I ask Python, what's B plus 4? It's going to say, what's B? B's not defined. I can't add that. B has no value. There's no integer in a thing called B that I can add another integer to. This is not an option because it doesn't exist. We could make it exist. Okay, so now here's a big test. Take your time. I already hit run on the code above, and I'm going to hit run on print B plus 4. Take 2 seconds, think about what you think the answer is. Now I'm going to go hit run. Raise your hand if you were right. Very, very, very good. If you're left scratching your head, It's very likely you're thinking too hard. Slow it down. Computer scientists are not bright enough to move that fast. You're trying to move fast. You're trying to look for shortcuts. There are none. If you're looking for a silver bullet trick, there isn't one. Here's the trick. Just follow the steps as simply as possible. That's the trick. So let's look. A equals 3. Now, actually, you might notice, who here is who likes math? So, for those of you that like math, or those of you that are at least familiar with math, note that the equal sign in Python and many programming languages isn't exactly, it is not the same thing as equals in mathematics. In programming, it's an assignment operator. It says assign the value of whatever's on the right-hand side to whatever's on the left-hand side. We will look at equality very soon, but in math, it's like a statement of fact. Like this equals that, that's the way it is. Here it's an assignment. It's saying, okay, A, you're now 5. By the way. Anyways, what does it say? A is 3. So what value does A have? Everybody yell it. Whoa. Let's get rid of this. This is not relevant. Is there even? Yes, there is. The first line of code, what is A? 3. Great. So we go to the next line of code. B equals A plus 2. Now always remember, we evaluate the right-hand side and then put on the left-hand side. So it's going to say A plus 2. But what's A?
3.
Okay, so we have the value 3 plus the literal 2. What is that? 5. Where do we put it? B. And then we go down to the next line that says B plus 4. What is B? What is the value 5 plus the literal 4? 9. Print it out. That's it. Don't skip steps. Skipping steps, huge mistake. And I'm not being silly. I'm not just saying that because, oh, you're learning. I'm saying that because that's what, do not, computer science skipping steps, bad idea. That's what's actually kind of handy about computer science is you get everything's so broken down. And another really cool thing, too, is if you write some code and you're not sure if you're right or wrong, hit run and see if you're right or wrong. Think of all the other disciplines where you get a question and you're like, I think this is the answer. Computer science, we have the luxury of being like, I think this is the answer. Let's test it. Oh, no, it's not. It's pretty cool, actually. Not many disciplines give us that luxury. So there we go. Yeah, I already said that. What can we do with variables? Well, I kind of spoiled the fun there in that little rant I went on. But yeah, that's some examples. We can store the values and then use them later wherever we can use values. Pretty cool. Imagine we have an equation we want to figure out. We can put in values, and then later, let's say I've got a special mathematical equation. A times A plus B. So this is just A squared plus B. That's it. I hit run. And now I'm going to print out C. So what's 3 squared? Well, that's 9 plus B. That should be 14, right? Perfect. Great. So this is my line 3 there. That's my super important function. Very, very, very important, right? And if you're here thinking yeah, but that only gave you the value for one thing. It's not But here's what's great about it. What if you're well, what happens if I just change? I'm going to leave B alone, but now I can recalculate it again by making it 30. And then go down here. Wow. We can just change these things out. And the function doesn't change because we're using variables. So we get to leave that little, I really shouldn't use the word function here. Let's call it that equation, that statement, that expression. A times A plus B gets calculated, and it's fixed. The fact that it says A times A plus B, that doesn't change. But I can change the values in the variables. Pretty cool. Because otherwise I'd have to do something like this. Okay, 30, 35. And you might not think that's a big deal, but imagine you had a much more complex little expression there. Yeah?
Can you use that for like a system of equations?
Oh, well, you can, yes, eventually. You can do whatever you want with programming. Except say something like this statement is false, otherwise you're in big trouble. We will learn so many more fancy, awesome, cool things that question is going to be like, oh man, like we can do that and then so much more. Like we're going to learn so much. Near the end of the class, if we get as far as I want, I'll even show you some very simple intro machine learning stuff. I mean, you're not going to be like a wizard at it, but I'm going to kind of show you some really cool things. Just give you like, tip of the iceberg of all the fun stuff you can do. All right, so just to make sure everyone's getting happy everyone's happy with what we've done, let's do this one together. Or well, you try it for a couple minutes and then I'll do it just so we're all on the same page. Take your time and go through this little activity. Assign various values of types, strings, integers, whatever to variables and just play around with them. See what you can do. This type of activity of just try stuff. See what you can do with it is one of the best ways to learn this stuff. Just get your hands dirty and we're lucky. Don't worry, you're not going to blow your computer up. Who here tried to add two integers together? Raise your hand. Did it work? Did it?
Yes.
Yeah. Is that surprising to you? No. Did you try to add two floats together?
Yes.
Did it work?
Yes.
Yeah. Did anyone try to add two strings together?
Yes.
Yes? Did it work?
Yes.
Let's see. E plus F. Oops.
Space in between.
That's not what I want. What did it do? What did it do? What happened when I added E plus F together?
Just wrote E and then wrote F right after.
Yeah, it like concatenated the strings together. It stuck them together. Interesting. So it looks like the plus operator, which you're all familiar with. Who here has ever used the plus sign before, ever in your life? Of course, everybody. What does it mean if I give you a number plus another number? Well, it means you combine them. So now we're seeing the plus operator used on something that's not numbers. So this is a little different, but it seems as if that, as far as Python's concerned, it's defined such that if you use plus with two strings, it just concatenates them. Who tried to add a, oh, you had a question?
Yeah, is there a difference between like the quotes on hello and the one on sun?
Ah, fantastic question. I didn't even do that on purpose. So, in other programming languages, like some of your more classical ones, let's say like Java or C, C++, let's say C++. A single quote is something you use for a single character only. Double quotes is reserved for strings. In Python, you can use either. So it doesn't really matter, and in fact, in this context, it doesn't really matter. But, like, if in here I wanted to, like, use that symbol, it lets me, but if in here I try to use it, it won't. There's a couple other funny little things, but that's kind of it as of right now. Good question, though. So what happens if I add A plus C? Who here thinks it's going to work? Raise your hand if you think, yeah, fine, it'll work. Raise your hand if you're like, no, it won't work. They're different types. You're right, it's different types. But Python's smart enough to be like, all right, fine, whatever, I'll do it. Python's being nice to us. You're right for thinking, I don't know. What happens if I do like, let's say E plus C? Do you think this is going to work? E plus C. No. We can't add an integer and a string. Shoot. Who tried doing this? 5 equals A. Did it work? Well, let's test it. 5 equals A. Whoop. The rule for assigning stuff is the thing that we want to put into the variable is on the right-hand side. So the thing on the right-hand side must be like a value. Asterisk. The thing on the left side must be something we can put it into. So 5 is the literal. And it's like I'm trying to say, well, okay, A currently actually has a value. I don't remember what I called it up there, like 6 or something. Just one sec. So I'm like saying, take the value of A and put it into 5. But Python's going, no, I can't. 5 is the literal integer. I can't change that. It's 5. You had a question? Yeah.
Technically, if you put quotations around the A and you make it a string, could then the box be called 5?
Nope. This is one of the rules that we will get to if we have time, which I think we might be running out of right now. There are a couple of limitations on what we can call our variables. We can call our variables almost anything. I've been calling them things like A equals 6. It's fine. I can say, no, wait, that won't work. Equals 7. And it's fine with that. I mean, that's a pretty dumb variable name, but I can do that. But there are a couple of rules. There are a couple of symbols we're not allowed to use. So if I do something like this, it's going to be like, that's not going to work. And it can't be a single number or be a variable that begins with a number. That's just one of the rules. One of the workarounds is to add an underscore if you really want it to start with a number. But anyways, great question. And we will come back to that next time, I guess Tuesday. Now, we do have Ethan over here, who's going to talk a little bit about the Math Stats Computer Science Club and the tutorials. So we'll turn the room over to him.
Thanks, James. Hi, everyone. My name's Ethan. I'm the treasurer for the Math Stats and CS Society this year. Long story short, you don't have to be in Math Stats or CS if you're taking a computer science course or a math course or a stats course. You're more than welcome to join. We're still trying to figure out all the details, but we put on free tutorials for anybody who has any questions. If you guys can't make it to your professor's office hours, or if you have an assignment due the next day and James is office hours are booked up, because that happened a lot during my first year. Yeah, you're more than welcome to come. We have a Facebook group. I'll put my email just on the board, and then you guys can email me and I'll just send you the link and you can join. Everyone see that?
Here, what is it? I'll just type it in here.
Oh, okay. X 2018 ZBF, and then @SNFX.ca.
There you go.
But yeah, so if you guys are, like, I'm a third year, I'm in computer science, so I've done all of this stuff and next semester and everything as well. And if anyone's taking calculus, the other 3 girls that are on the executive team are all math majors, so they also know what they're doing, a lot more than I would anyways.
Same with me. Don't ask me calculus.
I forgot it after I wrote my final in first year. But yeah, so if you guys want, just send me an email, and you can have the heading as like MSCS or something, and then type whatever you want in the actual text of the email, and I'll just send you guys the link and reply to it. So you're more than welcome to join if you want. And yeah, I guess that's it.
Thanks, Ethan. Yeah. So, I suppose in typical years it was like what? Monday, Tuesday nights or something?
Yeah, Monday, Tuesday nights.
It was like one of the nights of the week. They would be in one of the computer labs, and it was like pop in, students go, they get help, maybe students work together a little bit. It was a great environment. It's going to be weird this year, but it's still something that you could and should take advantage of if you can. Another thing too is it's just there is the Math Science Computer Science Club in general too.
Yeah.
That again, it'll be a weird year, but
Yeah,
it exists.
Yeah, we usually do, we'll try and do 1 or 2 like pizza parties or socials or something where you can meet your professors and everything outside of this kind of a setting. So if you're interested and you're like in Maths after CS and you like one of your profs, you can talk to them about research or networking or whatever you want to talk to them about really in general. But yeah, we're probably looking at doing it over Blackboard this year, so it'd be over your computer. If we can figure out something in person, that would be great. Or maybe we'll try and do 2 rooms like across the hall from each other, and then we just bounce back and forth. But we'll post in the group chat whenever we get it figured out. We'll hopefully have it done for next weekend ideally, but we're not 100% sure yet on how it's all going to work. But we'll keep you guys posted. So
Thank you.
yeah.
All right, thank you. Yay. All right. 2 other things. One of them is actually very related to what he just said. Is there's also programming competition stuff. So I know you're in first year and you might think like, oh, well, what can I? No. It's designed like there will be prep and learning and whatnot, where you kind of get a chance to just go and work on some interesting, fun little programming problems and learn a little bit about programming competition environments and tips and tricks in programming and whatnot. It's great to get started in this stuff as early as you can, even though you might not be going to compete. But start now, so maybe next year you compete or something, you know? So other than that, is there any questions about anything before we end today? Really? All right. You just want to leave. All right, see you. Have a good weekend.